In this lesson, we're going to explore exponents and product rules for those with like bases. So at the end of this lesson, you should be able to answer the question, how can I use product rules to simplify powers with like bases? So let's establish some vocabulary. In the expression that you see on the screen, the base is 5, whereas 3 is known as the exponent. This is often read as 5 to the third power. It's also known as 5 cubed. When I say power, often students think that the exponent is also the power, but really the entire expression is known as the power. Okay, so let's look at how 5 to the third power is expanded. The exponent means that the 5 is written there as a product 3 times. The base is repeated 3 times, so this would be equivalent to 125. But what I really want to stress, because you probably already knew that, is the difference between the next two expressions. And it's really about what is the base. So in the first expression, -2 is there as a factor 4 times. Whereas in the next expression, 2 is there as a factor 4 times, and that negative sign is just floating out front because the exponent is only raising the 4, or is only raising the 2 to the 4th power. So when you go to evaluate it, the first one becomes positive 16, whereas the second expression is negative 16. Now let's really get into our rules, which is our focus of this lesson. So when I have 4 to the third power times 4 to the 5th, notice that that is equivalent to 3 4s times 5 more. So how many I have altogether? There are 8 of them there. So let's look at what happens when I have the next expression. 7 cubed would be 7 times 7 times 7. And then I have times 7 squared. Well, altogether, that's 5 7s, which would be 7 to the 5th power. In the next one, I have negative 15 there twice. And then it's there 6 times as a factor in my next expression. So altogether, negative 15 is listed as a factor a total of 8 times. So this would be negative 15, I keep missing my 1, to the 8th power. Make sure you have parentheses around the base. B cubed means b is there as a factor 3 times, times b to the 4th means b is there as a factor 4 times. So altogether, I have b as a factor 7 times. This last one, 5 cubed times 3 to the 2nd, also known as 3 squared, means I have 5 cubed times 3 squared. I can't combine 5 and 3 because they're not the same. This is just 5 cubed times 3 squared. So if we look at, is there a shortcut? Is there a way that I could bypass this entire middle part? And you probably saw it pretty quickly because this takes quite a while to do all of this. So is there a way I can just skip that? Well, hopefully you noticed that 7 cubed times 7 squared ends up being 7 to the 5th, where I keep the base and add the exponents. Same with the next one, b cubed times b to the 4th, keep my base, add my exponents. Now the last one, the bases weren't the same. I can't make this be I can't make this be like 8 or 15 to the 5th power because it's not listed as a factor that many times. It's just 5 cubed times 3 squared. So the rule for if I have powers with like bases, I keep the base and I add the exponents. So let's apply this rule. In these problems it says simplify each expression and write your answer using exponents. So in this one, 4 to the 11th power times 4 to the 6th power, I keep the base and I add 11 plus 6 to get 4 to the 17th. In number 2, one of the things that you can do until you get really good at this is rewrite your product, because this is 2 times a cubed times 5a squared. So I'm going to rewrite it by the commutative property, which is 2 times 5 times a cubed times a squared. And then I see that my coefficients, well, that's just 10. That multiplication happens in the same manner it always has. A cubed times a squared is keep my base and add my exponents, so it's 10a to the 5th. Number 3, if I rewrite this, c times c cubed times d to the 6th times d, and c would be the same as c to the 1st. So this gives me c to the 4th power, d to the 7th power. Notice I put my variables in alphabetical order. That's one of those things that we do in algebra to make our lives easier. So in number 4, I'm going to rewrite this by the commutative property since it's all held by multiplication. And I put my coefficients first. 4 times 2 is 8. Then I keep my base with the x's and add my exponents, so x to the 4th and then y to the 6th. My coefficient in number 5, this would be a -1 right here, so you might need to write that in. So I have -1 times 3, then I go alphabetical order, times m to the 5th, times p to the 9th. So this would be -3, m to the 5th power, and then p to the 10th power, because 1 plus 9. Number 6, again, this -x means I have a coefficient of -1, times 2 times 3, alphabetical order with my variables, x cubed times x, times y to the 5th times y squared. This gives me -6, x to the 4th power, y to the 7th power. Now, let's see if we notice another pattern. When I have 4 squared raised to the 5th power, notice that that means that 4 squared is there as a factor 4 times, and then I can expand each of those further to see that I have a total of 10 factors of 4. So I'm going to expand 7 cubed raised to the 4th power. So I can see that what I have is like bases where I could apply my previous rule of keep the base and add those exponents, which would be 12. Or, if I don't thoroughly see that, I could expand each of them further. If I break each of those into 3 factors of 7, I again see that I have a total of 12 factors of 7, so this would be 7 to the 12th power. Now, in the next one, I have the product of ab cubed all raised to the 2nd power, so I'm going to start by expanding that, which gives me ab cubed times ab cubed. I could expand that even further to see what I really have. And hopefully you'll see that I have 2 factors of a, so a to the 2nd, and a total of 6 factors of b, b to the 6th. So again, I want to see if there's a way that I can bypass this middle row and middle column. I'm sure you've seen it. Rather than adding my exponents, if I start with 4 squared raised to the 5th, I have a power raised to another power. An exponent to an exponent is 4 to the 10th power. I keep my base and I multiply my exponents. In the final one, when I have a b cubed all raised to the 2nd power, hopefully you see that both factors inside end up being raised to the 2nd to get a to the 2nd, and then b to the 3rd to the 2nd. I end up keeping my base and multiplying my exponents. So the 2 rules that you should hopefully see is a to the m power raised to the nth power results in keep your base and multiply your exponents. So a to the m times n power. If I have the power of a product, so I have a product in here as the base, I need to raise each of them to the mth power. So a to the mth power, b to the mth power. I think of this as if I'm distributing this exponent to both factors inside the parentheses. So let's put this into practice. So I have 2k cubed raised to the 4th. I just realized I skipped one. Let's start with this one. 5 squared raised to the 6th power. So I keep my base and I multiply my exponents to get 5 to the 12th power. Likewise, in number 2, keep my base, multiply 8 times 3, and I get m to the 24th power. Now, at any time that you forget your rules, you can always go back to expanding things, because if you don't see the shortcut, then you have to do things the long way. In number 3, I need to raise each of these to the 4th power. So I think of it as if I'm distributing my exponents. So that gives me 2 to the 4th, and then k to the, keep my base, multiply my exponents, k to the 12th. Now I can figure out what 2 to the 4th is. That would be 16. k to the 12th power. Likewise, in number 4, I need to raise each factor inside the base to the 5th power. So 3 to the 5th, a to the, keep my base multiply, 15th, and b to the 10th. You can figure out what 3 to the 5th power is. It should be 243, a to the 15th, b to the 10th. So hopefully you see how to use product rules to figure out how to simplify expressions much faster. And again, at any time that you forget your rules, go back to expanding to rediscover your rules.